Hey guys, welcome back to Car Academy. In the last video, we looked into the NVIDIA Cuda programming model architecture, CPU versus GPU comparison, and then the device memory model, CUDA grids, blocks, and threads. I will give you a quick recap of what we have covered in the last video. Each kernel gets access to a grid, and a grid consists of two-dimensional blocks, and each block consists of three-dimensional threads. So at a high level, each grid we can access different blocks using x and y coordinates, and within each block we can access multiple threads using x, y, and z coordinates. We'll get into the programming about how to define these parameters of number of threads, number of threads per block, and number of blocks per grid, and things like that shortly. So a quick summary is basically a kernel gets access to a grid, and each grid consists of different number of two-dimensional blocks, and each block consists of different number of three-dimensional threads. One thing to remember is each block will have the same number of threads, so that is something you will have to remember. Each block cannot have different number of threads. Each block will have the same number of threads. Okay, now let's dive into the programming. So in order to go into the program, in the last video we looked into getting the device properties. Now in this video we'll look into defining a kernel, running them in parallel, and things like that. Okay, so to start with, let's start with a simple program. Now let's define a kernel. You all know a kernel is defined with underscore underscore global, and then a return type which usually is void, and you can give any name to the kernel. Okay, now let's print GPU kernel in this GPU kernel. Okay, now let's launch this. You know, we print something in the CPU, so CPU processing, and when we launch the kernel, a kernel will be launched with three angle brackets. Okay, so here we give 1 and then the parentheses. Okay, and in order to synchronize the host and the device, we call CUDA device synchronize API and return 0 to the operating system. Now let's compile this program. Okay, so there is an error. Okay, so I think the error is basically because we gave stdio.h. So let's change that to IO stream. Now we should get rid of this error. Yeah, so run this program. You see CPU processing, and we got a message printed from the kernel saying that GPU kernel. Now let's modify this program. Instead of 1, let's type 5 here and see what happens. NVC program02.cu, and let's run a.out. Now you can see the CPU processing has been printed once, whereas the GPU kernel has been printed 5 times. What that means is we have basically launched 5 threads in the GPU, which basically does the same operation of just printing the same message in all the threads. So we launched 5 different threads, and all 5 different threads printed pretty much the same message. Now let's see how to differentiate this. Okay, so in order to differentiate this, I'm going to do something like, so GPU kernel here let's print the thread index. So I was saying each thread, so let's print the thread index. So the thread index is something like you get, okay, thread index dot x. Now let's go and print this. I was saying you that in the slides that each block will have three-dimensional threads, but for now I have only allocated one-dimensional threads. We'll look into the details of how to allocate three-dimensional threads and two-dimensional blocks and things like that shortly. But for now, the way I have done is basically, so I gave a one-dimensional number here. One is basically for number of the blocks. I gave the number of blocks as 1 and I gave the number of threads as 5. Okay, so that's why you see each this message has been printed 5 times, but each message is printed with a different thread index. Okay, so you basically can access the data at different locations from different threads using this thread index. Okay, so the CUDA runtime will automatically allocate or assign thread indexes for each thread. Now let's go and modify this yet another time. Now at this time I will add one more thing, which is called block index. I would say block index dot x. Okay, so similarly here I would say thread index dot x. Let me remove the GPU kernel, and here for the first one let's print block index dot x. Okay, now let's compile this program, print this. So when you print this, you see we have allocated only one block, so that's why each thread just printed with the same block index 0, whereas the thread we have launched 5 different threads and we see 0 1 2 3 4, which is basically 5 threads. Now let's go and modify this program again. So instead of one block, let's allocate 2 blocks. So when we allocate 2 blocks, let's compile this program again. Now we allocated 2 blocks and 5 threads. Okay, now you can see there are 10 messages. The first 5 messages you can see has a block index value 0 and thread index starting from 0 to 4, and the next 5 messages are basically corresponding to the block index 1 and thread index 0 to 4. So if I have to explain this, let's go back to the slides. Okay, so let's go to the slides. Now let me explain how this works. Okay, so the way it works is when we have 1 comma 1, okay, so when we have 1 comma 1, this is basically one block and one thread. Okay, now I changed from 1 comma 1 to 1 comma 5. In that case, what happened is we allocated one block and 5 threads. So when we say 5 threads, these threads are basically corresponding to a block. Okay, I also told you that each block will have the same number of threads, and when we changed from 1 comma 5 to 2 comma 5, that means we allocated 2 blocks and 5 threads per block, and these are differentiated with block index and thread index. Okay, so when we give a one-dimensional number, we can access based on the x I think it's not block dimension, so let me correct that. It's basically block index.x. We will get into the details of dimensions shortly. So you see, we differentiated the threads based on these two different variables, thread index.x and block index.x. So let's forget about this block dimension.x for now. So when we say 2 is basically corresponding to block index.x 0 and 1, and 5 corresponds to thread indices 0, 1, 2, 3 and 4. Okay, and that is what we have seen. Now let's go and see how to access the other dimensions. Okay, so in order to see that, let's modify the program again. Okay, now let's say I'm going to add one more thing here. So let's say block index.y. Okay, let's add the block index.y. Similarly, let's add thread index.y %d, thread index.z %d. So here we'll have to print block index.y, comma, let's print this in a new line. Thread index.y. Okay. For the same program 2, 5, I'm going to print and see what happens. Okay. So here it says the format string requires additional arguments. Okay, let's see what okay. So we'll also have to print thread index dot z. Okay. Let's print now. So you can see now for all the 10 messages, the block index.y remains 0. Similarly, thread index.y remains 0. Thread index.z remains 0. Whereas only the x and y indices have changed. That's because we allocated only one dimensional block and one dimensional thread. Okay, so the way it looks like is basically, let me erase this. Okay, so when we say when we say 2, 5, what happens is we have a grid. Okay, so this is the grid, and this grid has two blocks, just two blocks, one dimensional block. This is block 0, this is block 1, and each block has 5 threads, again one dimensional, 0, 1, 2, 3 and 4. Okay, so that's how it looks like when we define 2, 5. So 2 blocks and 5 threads per block, 5 threads per block. So these 5 threads correspond to this block, and these 5 threads correspond to this block, which ranges from 0, 1, 2, 3, 4. So it's a single dimensional one. Now let's go and see how to define multi-dimension threads first. Okay, so in order to do that, let's modify the same program. In order to define multi-dimensional threads, we will have to use something like a dim3. This is nothing but a C structure where we will have to give the 3-dimensional thread numbers. Okay, so I'm going to use a dim block variable, and here I would say I want x3 and 2y and 1z. Okay, so this is basically x comma y comma z. Okay, Now let's go and compile this. NVCC program 02.cu. Okay, there's some warning, dim block was declared but never used. Okay, let's go and fix that. We just defined but never used. So this has to be used here. Instead of 5, now I have to give dim block. So see 2 comma dim block. Okay, now let's compile this program again. Now there is no warning. Let's go and run this program. So now when I run, you can see that I have block index 0 and 1. Okay, block index dot x 0 and 1, whereas block index y is completely 0, and you can see thread index is 0 1 2 0 1 2 0 1 2 0 1 2, and thread index y you can see 0 1 0 1. Okay, so what we have defined now is, now let's go and take a look at this again. Okay, so let me re-enable pen. Okay, so what we have done now is we gave dim3 a dim block 3 comma 2 comma 1. Okay, so this is x, this is y, z1. Okay, and then we launch, sorry, we launch the kernel with 2 blocks, and each block having, okay, so each block having total number of 6 threads, and these 6 threads are organized in a two-dimensional fashion where let me draw this block diagram so that you can understand. Okay, as same, we have defined two one-dimensional block, which is block 0 and block 1. Okay, and now I have defined a two-dimensional block, okay, which looks like this. So each block has a 2 by 3. So you have 0 comma 0, 0 comma 1, 0 comma 2. Okay, and you have 1 comma 0, 1 comma 1, and 1 comma 2. Same here. Okay, so each block has 2 rows and 3 columns. Okay, so that is what we have seen here. Now if you come and see here, okay, so this is one full block. Okay, now let's take just a block. Okay, so you are seeing block index dot x 0, block index dot y is 0 for all the messages, so we differentiate with the block index dot x 0, and within the block index dot 0 you see y varies from 0 and 1, which is aligning with what we have here. Okay, 0 and 1, and x is varying from 0 1 to 0 1 2. Okay, so that is what we see here, 0 1 2 0 1 2, right? Okay, so similarly for block index 1 you are seeing thread index dot y is 0 and 1, whereas thread index x is 0 1 2 0 1 2. Okay, now let's go and define multi-dimensional blocks. Okay, so that is something called grid dimension. Okay, so in this case what I will do is I will just give 2 comma 2. Since it's a two-dimensional, I will, okay, so let's give 2 comma 2. Okay, and here I will give dim grid. Okay, now let's go and compile this program. ./a.out. Okay, now you can see the block index dot y has varied from 0 1 0 1, and within that you can see block index Yeah, block index dot y0 has block index x0 and block index x1. Similarly, block index y1, you can see it's block index dot x1 as well as block index dot x0. Okay, so here, and within this each thing, you can see thread index dot x varying from 01 to, similarly thread index dot y varies from 0101. So this looks like, now let's go to the slides and see how this looks like. Okay, now let's enable the pen. Okay, so what we have given now is we gave dim3 dim grid 2,2. So a grid can have only two-dimensional blocks, and a block can have three-dimensional threads. Okay, the name might be confusing, but basically dimensions of blocks, I'll basically add some more thing. So I gave 3 comma 2 comma 1. Okay, so now this look like this. So each grid now has we now have block 0 comma 0 0 comma 1 1 comma 1 and 1 comma 2. Okay, this is basically blocks, and each block now have I'm not showing the z dimension because that is just one. Okay, so here you can see 0 comma 0 0 comma 1 0 comma 2 1 comma 0 1 comma 1 1 comma 2. Okay, so each block has these two-dimensional threads. This is basically threads. Okay, so that is what we have just written. Okay, I want to add one more thing here for the sake of completeness. So I want to print one more thing in the kernel, which is called the dimensions. Okay, so the dimension is basically block dimension dot x percentage d, block dimension dot y percentage d. Similarly, grid dimension dot x percentage d, grid dimension dot y percentage d. Okay, so that has to be printed here. Block dim dot x, block dim dot y, grid dim dot x, grid dim dot y. Okay, now let's go and print this program, compile this program and print the messages. Here you can see block dimension dot x is 3, block dimension dot y is 2, grid dimension dot x is 2, and grid dimension dot y is 2 for all the messages. Okay, what this means is this is nothing but we have allocated 2 by 2 blocks in each grid. Okay, so that is why we are seeing grid dimension dot x. Okay, so there are two blocks in x direction in a grid and two blocks in the y dimension in the grid. Okay, so which is 2 by 2. Similarly, each block has three threads in the x direction and two threads in the y direction. So 3 comma 2, I did not print dot z because we know it's 1. So you can see it's a 3 comma 2. So there's a 3 comma 2 3 by 2 threads in each blocks. So you can also get to know the dimensions of the block and also dimensions of the grid by accessing these variables. Okay, so if you take a look at this, the 2 comma 2 comes from this. Okay, and the 3 comma 2 comes from this. So that's all I wanted to cover in this video. If you like this video, subscribe to this channel, like this video, share it with your friends. Until I find the next interesting topic in the CUDA programming, I'm signing off. Follow the channel Car Academy for more interesting videos like this in the space of AI, machine learning, NVIDIA Cuda programming, and any other programming topics. Take care, guys. Bye.